Hi everyone, welcome back to Lulumath. This video is going to cover another transformation of functions problem, and this time we're going to be looking at a square root example. And the background knowledge you'll need is the video on transformations of functions part 5. This video brings all of the transformations together, and it goes in depth how the transformations all work together. So just a reminder that our general equation is y equals a times f of k multiplied by the quantity x minus d plus c. Let's have a reminder of what each one of these colored parameters represents. So the a value represents a vertical stretch if the absolute value of a is greater than 1, and it represents a compression if the absolute value of a is between 0 and 1. Just a reminder, the sign of a does not affect whether it is stretched or compressed. And it also represents a vertical reflection or a reflection in the x-axis if a is negative. Now the k value represents a horizontal stretch, and a really important reminder is that the scale factor has to be 1 over k. You must do the inverse operation for our horizontal transformations. So if the absolute value of 1 over k is greater than 1, then it is a stretch. And if the absolute value of 1 over k is between 0 and 1, then it is a compression. And it could also represent a horizontal reflection if the k value is negative. And just a reminder that a horizontal reflection is a reflection in the x-axis. And then the d value represents a horizontal translation. And if d is greater than 0 or positive, it shifts right. And if d is less than 0 or negative, it will shift left. But don't forget to take that minus sign into consideration. And the c value represents a vertical translation. And if c is greater than 0 or if it's positive, it shifts up. And if c is less than 0 or if it's negative, it shifts down. And a super important reminder is that the k value has to be factored out. So this k right here must be k multiplied by the quantity x minus d. All right, so let's apply that information to this question. Consider the function h of x is equal to -4 multiplied by the square root of -1 over 3x plus 6 plus 7. Determine the parent function and describe the transformations done to the parent function to result in h of x, and then graph the function. So for starters, if the k value is not factored out, it needs to be factored out. And this -1/3 right here is the k value. So we are going to factor out a -1/3. And when I factor that out of -1/3 x, I have an x left over. Now remember, when we factor, we're dividing. So when I factor out the -1/3 from 6, I'm taking 6 and dividing it by -1/3. But when you divide by -1/3, that's the same thing as multiplying by the reciprocal. So you get -18. So really here, this should say -18. Now, to make sure we did it correctly, let's go ahead and distribute and see if we end up getting this expression here. So -1/3 times x is -1/3 x, which is what we want. And then -1/3 times -18 is +6, which is what we want up here. One thing up here that I forgot to mention is this f right here represents our function rule. And that tells us what our parent function is. So our function rule could be squared. That tells us that we're looking at a quadratic graph. It could be absolute value. It could be square root, which is what we're going to be looking at here. So if you see here, this square root right here is telling us our function rule. Now I'll copy the rest of this down. So I've got -4 and +7. And one thing I want you to be careful of when you're factoring out this k is that it is not 1/3 multiplied by x, and then people will see the 6 and divide it by 3 and say it'll be x minus 2, because they'll forget that they're dividing by -1/3 and they're not multiplying by -1/3, and they forget to do the reciprocal. But this doesn't make sense, because when I distribute -1/3 through to this -2, that gives us +2/3, not the 6 that we're looking for. And that's why it has to be -18. So this tells us what our transformations are going to be. Our a value is -4, and that tells us two things. It tells us that we have a vertical stretch with a scale factor of 4. And it also tells us that we have a reflection in the x-axis. And we know that because the a value is negative. The k value is negative 1/3. So that tells us that 1 over k is equal to negative 3 because the reciprocal of negative 1/3 is negative 3. So this tells us two pieces of information. We have a horizontal stretch with a scale factor of 3. And we also have a reflection in the y-axis because the k value is negative. We know that the d value is 18, and we know it is positive 18 because the format is x minus d, and since this is minus 18, then d is positive 18. And this tells us that we have a horizontal translation or shift 18 units to the right. And our c value is equal to positive 7, the c value here. So we know that that is a vertical translation 7 units up. All right, now we need to identify what our parent graph is. And we know our parent graph is this square root right here. So it's the square root of x. F of x equals the square root of x. So let's go ahead and make our chart for our parent graph. So we have x and we have f of x, and we are going to use numbers that we can easily square root. So I will use 0, 1, 4, 9, 16, and 25. Again, you don't have to use these numbers, but I'm trying to make things a little bit easier. And when I square root each one of these numbers, I get 0, 1, 2, 3, 4, and 5. Now we need to do our stretches or our compressions, our dilations, and those come from our scale factors here. So our scale factor is 3, but it is a negative 3. So we are going to multiply x values by negative 3. And here, because our a value is negative 4, we're going to multiply our y values by negative 4. So the heading here is negative 3x, and the heading over here is negative 4y. So when I multiply my first x value of 0 by negative 3, I get 0. When I multiply 1 by negative 3, I get negative 3. When I multiply 4 by negative 3, I get negative 12. When I multiply 9 by negative 3, I get negative 27. When I multiply 16 by negative 3, I get negative 48. And when I multiply 25 by negative 3, I get negative 75. Now when I do negative 4y, 0 times negative 4 is 0. 1 times negative 4 is negative 4. 2 times negative 4 is negative 8. 3 times negative 4 is negative 12. 4 times negative 4 is negative 16. And 5 times negative 4 is negative 20. So I've done my compressions and my stretches. I've done my dilations. Now I need to do my translations. And since d is equal to 18 and we're going 18 units to the right, we are going to add 18 to x. And because c is 7 and it's a vertical translation 7 units up, we are going to add 7 to y. So that means I will take this negative 3x and add 18 to it. So negative 3x here is 0. 0 plus 18 is 18. Negative 3 plus 18 is 15. Negative 12 plus 18 is 6. Negative 27 plus 18 is negative 9. Negative 48 plus 18 is negative 30. And negative 75 plus 18 is negative 57. Then I'm going to take my y values, my negative 4y, and I'm going to add 7 to it. So 0 plus 7 is 7. Negative 4 plus 7 is 3. Negative 8 plus 7 is negative 1. Negative 12 plus 7 is negative 5. Negative 16 plus 7 is negative 9. And negative 20 plus 7 is negative 13. And this right here represents the graph h of x. So I'm going to number and label my axes. This is my x-axis, this is my y-axis. And on my x-axis, I'm going to go up by 5s. So this is 5, 10. And on my y-axis, I'll go up by 2s. And I will go ahead and graph out my points. And this is a sketch of my graph. And it will go on forever in this direction, but this is my starting point for my square root function. So on that note, I would like to discuss the domain and the range of this graph. So we know that the x value will not go any farther past this point right here. So x has to be any number starting from here, which is at 18, and to the left of that 18. So we can say that the domain is x is an element of the reals such that x is less than or equal to this 18 that we have here. Or in interval notation, we can say it's from negative infinity to 18, not including negative infinity because we can never reach that point, but including 18 because 18 will work. And for our range, we know that our y value cannot go above this point since our x value cannot go past this point. And this point right here is 7. So we know that for our range, y is an element of the reals such that y is less than or equal to 7, or it goes from negative infinity to 7. Now, the reason why we've got less than signs here is because of our reflections, because normally our graph would go like this, and our graph starts on the left and goes to the right and starts from the bottom and goes to the top. However, because everything was reflected in the x and the y axis, they flipped. So instead of going from left to right, it now goes from right to left. And instead of going from down to up, it goes from up to down. And that's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye.